Vera Rubin, Kent Ford, and Ken Freeman's work in the 1960s and 1970s provided further strong evidence. Also using galaxy rotation curves, Rubin and Ford worked with a new spectrograph to measure the velocity curve of edge-on spiral galaxies with greater accuracy. This result was confirmed in 1978. An influential paper presented Rubin and Ford's results in 1980. They showed most galaxies must contain about 6 times as much dark as visible mass. Thus, by around 1980, the apparent need for dark matter was widely recognized as a major unsolved problem in astronomy. At the same time, Rubin and Ford were exploring optical rotation curves. Radio astronomers were making use of new radio telescopes to map the 21 cm line of atomic hydrogen in nearby galaxies. The radial distribution of interstellar atomic hydrogen, HI, often extends to much larger galactic radii than those accessible by optical studies, extending the sampling of rotation curves, and thus of the total mass distribution, to a new dynamical regime. Early mapping of Andromeda with the 300-foot telescope at Green Bank and the 250-foot dish at Jodrell Bank already showed the HI rotation curve did not trace the expected Keplerian decline. As more sensitive receivers became available, Morton Roberts and Robert Whitehurst were able to trace the rotational velocity of Andromeda to 30 kpc, much beyond the optical measurements, illustrating the advantage of tracing the gas disk at large radii. Figure 16 of that paper combines the optical data, the cluster of points at radii of less than 15 kpc with a single point further out, with the HI data between 20 to 30 kpc, exhibiting the flatness of the outer galaxy rotation curve. The solid curve peaking at the center is the optical surface density, while the other curve shows the cumulative mass, still rising linearly at the outermost measurement. In parallel, the use of interferometric arrays for extragalactic HI spectroscopy was being developed. In 1972, David Rogstad and Seth Shostak published HI rotation curves of 5 spirals mapped with the Owens Valley interferometer. The rotation curves of all 5 were very flat, suggesting very large values of mass to light ratio in the outer parts of their extended HI disks.